let's start your snap for RCC.
Sorry,
And
sir.
let's start your snap for RCC and introduce yourself before entering into the snap of RCC for IIT Madras MS program.
Yes, sir. Okay. So, my name is Siddhartha Bhomik, and I belong to Kachar district, Silchar, Assam. And I have done my schooling from Kendriya Vidyalaya, Silchar. After that, I joined B.Tech in civil engineering at NIT Silchar. Then I have completed my B.Tech last year with 9.23 CGPA. And I have a good knowledge in AutoCAD. I have done an online internship from IIT Guwahati, in which I have analyzed and designed a 6-story structure with StatPro software. And I have done my final year BTech project, in which the project was analysis and design of a 3-story residential building using StatPro software with structural detailing and manual calculations of all the building components. And uh, after that, so my interest is in structural dynamics and earthquake engineering. So I have done an online internship in this domain. Yes, during my BTech, I have a keen interest in structural dynamics and earthquake engineering. So, but the knowledge that I gained during BTech is not that sufficient because the domain is so vast that it cannot be completed within short duration. So MS research will be a great option in which I can advance my knowledge and do some fruitful work in this domain so that I can do some better thing to the society.
Okay, can you tell me, Siddhartha, what is the difference between this AutoCAD and StatPro software?
So AutoCAD is used for means architectural designing, like to draw the plan and to draw the means structural detailing part. And AutoCAD is used for the structural analysis. Means it is we can get the complete analysis of the structure. We can get the pattern of bending moment, shear force value. From that, we can get the idea about the behavior of structure.
Okay. So can you tell me what is the application of drawing this BMD?
So BMD is basically a graphical representation of bending moment. So it is used for means for knowing the means behavior of structure, like where there is sagging, where there is fogging bending moment, or to get the maximum value of the moment, the BMD can be used.
Okay, that is fine. We are getting where the sagging, where is hogging, but what is the application? Why we are going to know where it is sagging, where it is hogging? Why we want to know?
Because in RCC we have to provide the steel according to the means sagging and hogging bending moment. Like in hogging bending moment, we provide the steel in top side, top reinforcement we provide, and in sagging we provide the main steel in the bottom part. So that is the main means reason for knowing the BMD.
Okay. So you worked this with the software StatPro, right? You analyze the building. So can you tell me the wind code that you use there in the software?
Wind code is it is IS 1893 is for earthquake, and I forgot the code actually, sir.
Okay. Did you use the code in this StatPro?
Yes, I used.
Use,
Yes, sir. Yes.
Okay, suppose if we have to frame the load, what is the load that is coming to the structure and the code we are following? So which one code for the load?
Means, sir, we were talking about means dead load or live load.
Yes, yes, dead load, live load, snow load.
That is IS 1984 means part 1, part 2 is for dead load and live load, and part 3, part
IS 1984. Which one code is this? 1984 is kind of year of revision might be. What is the main figure that we have?
So suppose IS 456 is for plain and plain cement concrete, and IS 1893 for means earthquake resistant design. But the wind load I actually forgot.
Okay, no issue. As per this code IS 1893, the entire country has been divided into number of zones. What is that number?
So it is divided into 4 zones. That is zone 2, zone 3, zone 4, zone 5.
Okay, the structure that you analyze, it was falling in which zone?
I have analyzed the structure in northeast, and northeast comes under zone 5.
Entire northeast.
So basically, maximum region of northeast comes under zone 5.
So what do you consider? You consider the zone 5 for your analysis, right?
Yes, sir.
Okay, then. So how the earthquake resisting building is different from the normal building?
So an earthquake resistant building, we use the ductile detailing code like IS 13920, which is the ductile detailing code. In this code, from that code we have to do the detailing. Like in column, we use the special confining reinforcement, which is provided in every joint, so that it increases the ductility of the structure. In beam also there is a provision in this code, like we have to closely space the stirrups in the confining zone, and we have to provide a proper development length to the structure. And in
What
normal
is
build,
confining zone? That's a confining zone.
the confining zone, it is basically the zone which is near the every joint. Like in column, the confining zone is L naught, which is given by clear height by 6 or 450 mm, which is minimum that we take.
Clear height by 6 or 450 mm, whichever is less.
Yes.
Okay. Can you tell me which type of steel you will prefer for the earthquake resisting building?
So in earthquake resistant design, we can use Fe415, because it has if you use the very high grade, it has less ductility, and we want to increase the ductility in earthquake resistant design.
Why you are not going with the Fe250? That is the most ductile amongst all kind of steel that we have.
So basically in Fe250 the strength is less, but it has high ductility, but we want also the strength. So Fe415 has sufficient strength and ductility also.
Okay. Fine. So what was your project, Siddhartha?
So my project was analysis and design of 3-story residential building using StatPro software.
Okay. 3-story.
And another project was stability mitigation of river bank erosion. River bank erosion.
River bank erosion. Can you tell me what is the height of riser? What is the value of riser in the staircase?
Riser, can be 150 mm.
And tread?
Tread 250 mm, 250 to 300.
250 to 300. Okay. And minimum number of steps?
Minimum number of steps it can be calculated by knowing the height of the structure and the riser. So it can, if we divide the height by riser, we can get the number of steps.
That is fine. We are getting the number of steps. My question, minimum number of steps. At least it should be there. Minimum.
So for dog-legged staircase.
No, normal staircase.
So exact value I don't.
Okay. Okay. Can you define what is deep beam?
The deep beam is a beam in which the depth is high, and it can, in simply supported beam, we can define the deep beam as if the L by D ratio is less than 2, then it can be defined as deep beam. And in continuous beam, if the L by D ratio is less than 2.5, then it can be called as a deep beam. And in deep beam, we cannot neglect the shear deformation. That is, we cannot apply the flexure equation in deep beam because there will be warping of stress in deep beam because of the high depth.
So how will you take care that in the deep beam?
That is, I can't answer.
No issue. Can you tell me if we talk about RCC and PCC? The first, please define what is RCC and what is PCC.
So in RCC, we provide minimum percentage of steel. That is, in for beam we provide 0.85 by PD, and for slab that is 0.12% if it is a high grade steel. And in PCC, if you provide less than minimum percentage of steel, or if you don't provide steel at all, then it can be called as PCC.
Now there's an assumption in RCC whether WSM or LSM, entire compression is being taken care by the concrete and tension is being taken care by the steel.
Yes,
Okay.
sir.
How you come to know the assumption is holding good?
Sir, we can calculate the critical stress and the FCBT value, that is the bending tensile strength of concrete. If the FCBT value is greater than the critical compressive stress of concrete, critical tensile stress of concrete, then it is a cracked section. And in cracked section, we neglect the concrete on tension side, and by visual observation, if there is a cracks in the concrete, then it shows that the concrete has not the power to resist the tension, so the entire low tension is taken care of by the steel only.
Okay. My last question to you: if we have a structural component or element whose static indeterminacy is high, so
Okay.
is it beneficial for us or bad for us?
Static indeterminacy is high. So for analysis purpose, it can be difficult for us to analyze the structure. For example, if you take a fixed beam, or if you take a simply supported beam, so in fixed beam it has high static indeterminacy, and in simply supported beam it has no static indeterminacy. So in fixed beam, the bending moment will be less, so the deflection will be less, so it will be beneficial for us. But in simply supported, the bending moment, the deflection will be more, so it can be harmful for us.
Okay, okay, fine. So Siddhartha, let me give you feedback. See, your technical is okay. There's not a big flaws. But see that you did in this your training. You just go with the STAD Pro software. That is basically kind of the designing tool that we have. What is the recent tool that we are using in India?
ETABS.
ETABS. Okay, fine. Okay, so BMD. What is the application of BMD? That was okay. So if we have to provide the steel in the section, so we are coming to know where we have to provide the tensile reinforcement. Okay. So wind code. This is IS 875 part 3.
Yes, sir.
Okay. And the entire wind code, sorry, entire this loading code, IS 875 part 1, part 2, part 3, part
Yes,
4. This is a combination of load in the part 5. Okay.
Yes, sir.
And if we talk about the deep beam and the shear is more, so what we are doing in the deep beam, we are just going with the side face reinforcement. Na?
Yeah, yes.
We are
Right.
always going with the side face reinforcement. We are taking care of this spacing criteria also. Should not be more than the 300 mm. The torsion
Yes.
is acting, then we are not waiting for this 700 mm. We are just taking care. If it is more than 450 mm, then side face reinforcement we are providing. Okay.
Yes, sir.